today we're in section 3.4 using similar triangles. The concept here is really no different from the other sections that we've learned in chapter 3. It's dealing with angle measurements. All right, have we physically measured anything this chapter with a protractor? No, we haven't. So what we've done is we've found angle measurements purely by their relationships with each other and their properties of the polygon, whether it's triangle or a different polygon, you know, pentagon, hexagon, heptagon, whatnot. All right, so here we're looking at, are the triangles similar? And here's your main concept that you need to know. In order for triangles to be similar, we're looking for congruent angles, meaning they will have the same angle measures, the exact same. All right? Congruent angles is what we're looking for. So whatever combination that is, they have to be congruent. They have to be the same measure. So it might be a small triangle and then a much larger triangle, or I might flip it vertically or rotate it, but my angle measurements are still going to be the same. All right, so in example 1, I want you to go ahead and draw these triangles, and as you're just sketch them down real quick. As you're sketching them, I want you to just see what you notice about their angle measurements between the two triangles. All right, so go ahead and sketch them real quick. Okay, so I can clearly see, okay, that which angles are the same on both of them. 63. Okay, so what I don't know though, I know that this angle right here is 54, and I don't see a 54, but what if this x was a 54? It could be. Okay, so the only way to truly verify it would be to set up an equation, and it could be for either triangle. It doesn't matter which one, but set up an equation and solve for the unknown angle measurement. This is something that we did in section 3.2, so this is not a new concept for us to go ahead and just set up 54 plus 63 plus x equals 180, and we solve the equation. We solve for x. Go ahead and do that. Okay, so what's 54 plus 63, guys? What's 54 plus 63? 117 plus x equals 180. When I subtract 117 from both sides, what do I get? 63. Okay, so x equals 63. So here's what I want you to notice, and maybe even go ahead and just plug it back into the figure that you already drew. Okay? So now that I know what the third angle measurement is, okay, I can match up 63 and 63, both of those are each one of these angle measurements, okay? So if two of the angle measurements match up, do you agree you see 63s on both sides? Yes. Okay? Then the third angle measurement that I have not solved for yet has to be 54. It cannot be any other measurement because that triangle has to add up to 182, right? So here's what you know, okay? Once you know all three, are you listening? This is really important. It's the most important statement that I can make in this whole lesson. Once you know all three angle measurements on one of the triangles, if two of the angle measurements, and it could be any of them, but if two of the angle measurements match exactly to the other triangle, the third one, without even solving, has to be the other value. It has to be, okay? So I'm going to show you that part, but this is all you have to show. If two of the angles match, the third one has to match too, because it has to equal 180. But let's just do the second triangle so I can show you. What's 63 plus 63? Can anybody just tell me that real quick?
That's 126.
Okay. And then what's 180 minus 126?
That's 54.
Okay. So how many seconds, and guys, you don't even have to show all these steps, but how many seconds did it take you to verify that the third angle was 54? What, like 30 seconds? Okay. So if you want to be completely sure that the triangles are congruent, go ahead and solve for the other x. And now I can clearly see is 54, 54, 63, and 63 on both. So guys, I did all that work to answer this question. Yes. Yes, they're similar. because their angle measures are congruent. All right, so I've shown you one. Now let's do one together. Okay, or basically mostly independent. Okay, so I want to see how much of this next one you can do on your own. Again, doesn't matter which triangle you pick to solve for x. It does not matter which triangle you pick, but once you solve for x, at least two of the angles have to be exactly the same measure as the other triangle. If two of the angles are the exact same, it's yes. But if they're not, then it's no. So I want to see how much of this you can do on your own. Okay, so I just did the first triangle. I think some of you did the second. I actually accidentally said X instead of Y. That doesn't really matter. But you could have set up either triangle in an equation. You could have done either one. I just went ahead and solved the first one, and I found that X equaled 81. Okay, so when I plug in 81 here, here's what does check out. Okay, 28 and 28 match up. That's awesome. But now I'm looking for the second angle measure. I have to have another angle measurement in the first triangle that says 80. Do I have one that says 80?
No.
No. So it is impossible now for my X on my third one to be the same measure. It's impossible for them to be all the same measure. My answer is no. But if I just want to double check, I can solve for the other one too. And some of you solve for the other one to make 72. These are not the same angle measurements. All right, they're not similar. All right, the last thing you need to know, if you think back to chapter 2, we learned how to set up a proportion, all right, in chapter 2, and that's exactly what we're doing here in example 2. All right, in example 2, let's see, hold on, sorry, I'm having a little, there we go. All right, in example 2, we're dealing with similar triangles and proportions. Okay, we have a person who is 5 feet tall and casts a 10-foot long shadow. Okay, so you ready for my person? Go ahead and draw a person. Hey, there's my person. Oh, he's so cute. He's got little eyes and a smile. Okay, but look, guys, he's 5 feet tall. Okay, so he's 5 feet. And how long is my person's shadow? How long is his shadow? It's 10 feet. Okay? All right. So what did that just form? If I connect them together, it formed a triangle. All right. You see the connection? Okay. Now I have a tree. So draw your little tree. All right. All right. So here's my tree. It's been a while since I drew a tree, so forgive me. That's not really a super cute tree. Okay, how tall is my tree? I don't know. How long is the tree's shadow? Oh, do I? 60 feet. Okay, so again, what did that form? That formed a triangle, right? Okay. So you don't always need to draw a picture, but I wanted to show you a visual because that's the connection here that we're making into this lesson, that we're setting up. These are similar triangles because my person, he's only 5 feet tall, but his shadow is 10 feet. The tree is, don't know how tall, it said what is the height, but it casts a 60-foot long shadow. So I can set up a proportion now. There should be something that you remember from what we've already learned about proportions on how you set it up. I want you to try to set up your proportion based on what we've already learned, okay, and then we'll set it up together. All right, so just as a reminder, guys, when we set up a proportion, we have a fraction on one side and a fraction on the other side, and we have an equal sign. Maya, how did you set up your first fraction?
5, 10.
Okay, 5 over 10. Totally fine. She could have said 10 over 5. She could have actually said 5 over x, height over height, okay? Anyway, so this is how I would do it too. Height of the person over shadow. Height over shadow. So how does it have to be set up on the other side?
X over 60.
X over 60. Height over shadow. Again, it's much easier when you have a visual because you can clearly see which values match up. All right, and now what would I do to solve?
Cross products.
All right, so 5 times 60 is 300 equals 10x. I had a question earlier, do I need to show these steps? I understand that you could probably do it mental math, but we do need to show our steps because we're anticipating that these concepts are going to get harder, and knowing the steps is really important. It's really important because no matter how difficult the proportion is, if I know cross products and I know how to solve, I can still solve it, right? If you understand that, that's everything you need to know for your final section, chapter 3, section 3.4.